So this has to be true. If V star is truly a fixed point, right, something, so V star is truly a fixed point, then this will be 0. So otherwise it will be something greater than 0, right. So because of the fact of this being a norm. Huh? Yeah, there is no case for less than 0. So this is fine, right. All of this is the thing. So now what we will do is we will use our friend, the triangle inequality again. Like I said, it is very simple proof, right. All we are doing is just using the triangle inequality again and again, right. So use the triangle inequality again. So what we get? So what do we know? We know that Vn is Cauchy. So we know that Vn is Cauchy. So this sequence is going to this thing, right? V star minus Vn minus 1 is going to go to 0, right? I mean that is by definition of Cauchy sequence. V star minus Vn minus 1 will go to 0. Likewise, Vn minus V star will also go to 0 by virtue of the fact that Vn is Cauchy. Okay, that is the definition we had earlier, right? So that is going to converge, right? So it will go to 0. No. V star is the convergent point, right? So we know that V star, because of it being Banach, we know that V star exists in U, right? So that's the thing we had, right? Limit as n tends to infinity, Vn will go to V star. That is what we mean by saying it is convergent, right? Limit as n tends to infinity, Vn is going to V star. So limit as n tends to infinity, V star minus Vn will go to 0. Limit as n tends to infinity, that is the crucial point here, right? We are going to be doing this forever, and if the difference is going to be something small when it goes forever, that means it is not convergent. That is the assumption we have made. See, what I am trying to prove is that T V star equal to V star is a fixed point, right? That V star is a fixed point of T is what I am trying to prove, right? The fact that Vn is Cauchy, right, it tells me that if I apply T infinitely often enough, I will anyway converge to V star. It anyway reach V star. What I am trying to show is once you reach V star, you do not go anywhere, you just stop there under T. That makes sense. So the sequence I am generating Vn plus 1, Vn plus 2 and so on and so forth, I am showing that it is Cauchy, right. So that means that if I apply T infinitely often enough, I will eventually reach infinitely often, yeah, infinite should be enough. So if I apply T infinitely often, I will reach V star. Okay, so that process is there. What we are trying to show is, okay, V star is actually a fixed point. Once you reach V star, you are going nowhere.
So we could have just put m equal to 1 and n equal to and taken the limit n tends to infinity for that, the previous one. We got the equation for, yeah, that one.
What would you have gotten?
Plug in m equal to 1 and then
m equal to 1
tending to infinity, taken the limit.
Yeah, what would I have gotten?
Then we would have gotten that RHS becomes 0.
Okay.
And then
so you will show that it is the successive differences become 0.
But then that just Vn plus 1 is can be written as Tvn. So Tvn minus Vn will be less than or equal to 0. More.
Yeah, so essentially you will show that as it tends to infinity, it will become 0.
It will become 1 singular.
It will become 0, but you have to show that V star, if it reaches V star, it will stop there. That is all we are showing here. When it reaches V star, it won't go anywhere beyond V star, that is it, right. So we are just showing that it will stop at V star, that is basically what we are trying to show here. And since this is trivial. Yeah. In fact, we can actually show it that way also, okay, as limit n tends to infinity. Okay, now the uniqueness. From the contraction property, so u star and v star are two different fixed points for t. From the contraction property, we have t u star minus t v star should be less than or equal to lambda times u star minus v star, norm of u star minus v star. But since they are fixed points, the left hand side is also u star minus v star. So I am asking you for u star minus v star should be less than or equal to lambda times u star minus v star. For lambda non-zero lambda, that is satisfied only for if v star equal to u star. Oh sorry, no. If lambda is not 1, then it is satisfied for, yeah. So even if lambda is 0, it has to be that u star is equal to v star. Right?
And also if it is the negative side of the both,
what's it?
minus u star and minus v star, then norm is
doesn't matter, right? I mean, we are just using the contraction property. Just this is sufficient to show that u star has to be equal to v star. Right? So as long as lambda is not 1, and anyway we have excluded lambda 1 here, right? So as long as lambda is not equal to 1, so this implies that great. So what we have done so far is shown that the Banach fixed point theorem is correct. Right? We need to show that L pi is a contraction. So if you show L pi is a contraction, you get everything else for free. Right? So we need to show L pi is a contraction. So let us do that, and I will stop after that. Why don't people stop me? Okay. What do I do? V minus u, V minus u, sorry. Okay. So far it's just algebra. Okay. So now what I am going to say is, well, I don't care what j I am considering.
The confusion is the notation. So u and v are vectors, but u of s and v of s are scalars.
U of s and v of s are single increase in this.
But all the contraction mapping results are for vector norms, right? So I mean
all the contraction mapping results are so far for vector norms. Yeah.
So do element wise do they correspond to that? I mean the maximum of that particular vector has to be lesser than the maximum of another vector, but each element wise they need not be lesser.
Element wise they need not be lesser. No, that's not needed. Yeah. Only the max norm wise. Yeah, the max of this should be less than the max.
That expression is again for a scalar expression.
Whatever I'm writing so far is a scalar expression. Yeah. I'll come to the vector form of this. Okay. So far I'm writing scalar expression. Yeah. So now, so the tricky thing now I'm going to say, see I'm summing over all j, right? So I'm going to look at this expression. So what I'm going to say is this expression, right, will always be bounded by v minus u, right, the max norm. Right, so this is a pretty loose bound, right? So I am taking each element here, I am looking at this, right? Each element of this will be bounded at most by the max norm, right? So it can't be any greater than the max norm difference. Therefore, I will say that this expression is lesser than or equal to gamma times the max norm into that, right? So that anyway goes to 0. So this is essentially equal to, okay. So at every point this will satisfy that. Okay, this is one way. So go the other way. Well, you can do the other way easily enough, right? You will end up with the same thing. Norm of v minus u is the same of norm of u minus v. So you will end up with the same expression, right? So essentially I can say that. So I am assuming that you guys will finish the other way around. Okay. So what is otherwise is when L pi v of s is less than L pi u of s. Okay. So greater than, less than. So I am just assuming you guys will do that, right? Putting these things together gives us what? Right. So what can infer from this? So point wise it's being drawn closer, right, by gamma. So the max difference should also have come down. Point wise is being drawn closer, even if the max difference is at different points, right, it should have shrunk. right. So essentially that is it. So this essentially means that implies that L pi is a contraction. Okay. So next thing to do is to start the same thing for the optimality equation, right. So we will do that in the next class, and then I will have to also talk about.
How do you conclude that it's a contraction?
See, I am assuming that at every point, right, at every point the functions are being drawn closer. What is it?
What brings you to the attachment?
That's what, so I am saying that, see, L pi Vs minus L pi Us is closer, right, than the max difference that you had in V minus U, right, and this holds for all states, yes, right, and that yeah, the right hand side is infinity norm, left hand side is just absolute value. Okay. Yeah. So we also have to show algorithms for solving this, right, and so we will do all of that in the next class. Possibly it might spill over into the subsequent class as well.